Hello and welcome to another geometry example video. Today I'm going to be looking at similarity. I've already seen quite a few questions and misconceptions about what to do with these similar triangles. So I thought I would make another video to try to clear some things up. So first and foremost, big idea. Congruence is not the same as similar. Okay, this guy says is congruent, right? That means everything needs to be the same. All measurements, all the sides, all the angles are supposed to be exactly the same. These guys indicate similar. And I apologize for the confusion on notation. I told you about this symbol. The textbook actually uses this symbol for similarity. They both can mean similarity. The difference is that this one over here you often use in front of a number to indicate approximately. This value is approximately 7, and you might use a single squiggle there. That's why I prefer this one, just to separate those two. But point is, fewer squiggles than congruence leaves you with similar. And that means it's the same shape, but a different size. So the angles are going to match. Right? The angles will be congruent. The sides are not. The sides are going to be proportional. Okay? That means you can set up a ratio between two sides and set up another ratio between another two sides, and you get the same thing. That is what you are looking for to determine if the triangles are congruent. All right, so let's take a look at this problem right here. This is number 7 from 11.2, and it asks, is triangle PHY congruent? No. One squiggle. Is triangle PHY similar to triangle YHT? Then we want to say, is triangle PTY a right triangle? Explain why or why not. So first of all, we're looking at triangle P to H to Y. So that's this guy. Is it similar to YHT? Is it similar to this one? Okay. We have several tests for similarity. Let's just go back to the chapter here. Right? We had side, 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 angle, angle, angle. So if we can get all three of a kind, that's great. Angle, side, angle, angle, all work. And we then found out at the very end that side, angle, side works, side, side, angle does not. So that gives us 1, 2, 3, 4, 5. 5 different similarity tests that we could go after. So let's look at what information do we actually have in this one. For triangle PHY, we have two sides. And that's almost but not quite it. Do notice that this right angle will require this other side to also be a right angle. So right now we have a side, and an angle that's not included. Okay, that's no good as is. We're going to need a way to get more information or compare something else. Because on the other triangle, we have the right angle there, and we have one side. That's it. It looks like we don't have enough information to even begin. This is why I didn't include 7 in the homework, because it requires a lot more work. We first got to uncover that other side. If we could figure out a way to measure this side, notice that that side is shared between the two triangles, which means we would gain a measurement on both of them, which would be phenomenal. That's a whole lot of information. Okay, so how can we find the third side of triangle PHY, given that we already have two sides? That's right, the answer is Pythagorean theorem. So let's call that A, and we want to solve for A. We know that A is going to be equal to the square root of the hypotenuse, 20 squared, minus the other leg, 16 squared. You could do that math. Or 20 divided by 4 is 5. 16 divided by 4 is 4. Now what kind of triangle do I have? Now I have a 4 and a 5. Means ding, 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 special right triangle. This is one of our Pythagorean triples. It's a 3, 4, 5, which means A divided by 4 should also be our third side, the 3. So now I just have to multiply up because I divided before. Undo that. A has to be 3 times 4 is 12. Right? So that side there, that YH vertical component in the diagram, must be 12. Right, so that gives us all three sides of PHY, and it gives us two sides of YTH. Now, can we determine the third side of YTH? Absolutely we can, the exact same way. Look for a common factor between the sides that you know. 12 divides by 3, 15 divides by 3. So that gives us 4 and 5. Oh my gosh. There it is again. 4 and 5, which means the other side must be the side of 3. So something divided by 3 gives us 3. That's right. It's 9. So HT must be 9. Now we have all the measurements. We have all three sides of both triangles. So now we can set up any ratio you like. We can say hypotenuse 20 over 15. Right? So there's the hypotenuse to the hypotenuse. And then we'd go with, say, the long side, 16 to 12. Are those the same? Turns out, yes, they are. This divides by 5 to give 3, divide by 5 to get 4. This divides by 4 to get 3, and 16 divided by 4 to get 4. So I divided by different numbers on either side. That's okay. I was just reducing the fractions there. 20 over 15 is 4 over 3. 16 over 12 reduces to 4 over 3. 4 over 3 is equal to 4 over 3. It's an equivalent ratio. Therefore, it is a proportion. Therefore, these sides and these sides are proportional. Okay, is that enough? Well, we'd also want to set up one last one. Let's run the third side. Third side is the shortest side. So on the big triangle, the short side is 12. On the small triangle, the short side is 9. Does that reduce? Divide each of those by 3, which gives us 4 and 3. So it's still 4 over 3. Absolutely. The short sides also proportional. All three sides are proportional. Therefore, all three sides are similar. These are similar triangles, right? We can say unequivocally, is PHY similar to YHT? Yes, by the side, side, side similarity conjecture. All right? Now here's the next question. Let's go one step further. Is PTY a right triangle? PTY. I've got a lot of doodling all over. Let's clear this up a bit so we can see. PTY. So that's saying from PTY. Oh, that's the big one. The whole thing. we already saw that the two smaller triangles on the left and the right are both right triangles. I've drawn two right angles in there already, okay? But is the whole thing a right triangle? If so, its longest side is down here, which means the right angle must be here. Whoops. Should I be allowed to draw a square in there? Is that a right angle? Now, the only way it could be a right angle is if that whole big triangle is also similar to the other smaller ones, right? Because they are all right triangles. And if the big one is similar, then it must also be a right triangle. Okay? The angles all stay the same across similar triangles. It's the sides that change. So let's check. The big side of the biggest triangle is going to be both of these combined. It's going to be the 16 plus the 9. 16 plus 9 is 25. So let's set up hypotenuse of the large over hypotenuse of, let's just use the one on the left, 20. Okay? How about the shortest side? Okay, shortest side of the big triangle. Got to go in the same order. If I did big over left, then this has to be big over left, just using a different side of it. So the shortest side of the big triangle is this one right here. That would be 15. And the shortest side of the triangle on the left is that guy there, which we found that was, oh, I almost lost it, 12, right? Okay, reduce those fractions. 25 over 20. They both divisible by 5. That reduces to 5 over 4. 15 over 12. Both divisible by 3. That's going to reduce to 5 over 4 again. Oh my gosh. There you have it. 5/4 equals 5/4. Yes, those triangles are similar. Right? So, is it a right triangle? Yes. How do you know? Because it is similar to, actually, you're just using the symbol. You don't need the 2. The little symbol means similar to, or is similar to. It is similar to triangle CHY, right? Which is a right triangle. If you're similar to a right triangle, you must be another right triangle. Okay. So I hope that one more deep example gives you an idea of what it is you're looking for when you're testing for similarity, how this compares and contrasts to the check for congruence. It is a very similar process, but you are not looking for the exact same things. Do not use the word congruent and associated with triangles here whatsoever. You can say an angle is congruent. You could say these sides are congruent or are not congruent. They're almost all going to be not congruent, okay? Because if the sides are also congruent, well, then the triangle maybe is congruent or is not. Similar is kind of that middle ground, and if you're on one extreme or the other, then you don't have similarity either. All right, I tried to wrap it up, and then I ended up saying more stuff. So I'm just going to leave it there. There's your example. Make use of it. I hope you got something out of that. If not, you have further questions, please feel free to ask anywhere and everywhere all day long. I literally have nothing better to do right now. And on that disappointment, it's time to end the video. So long, farewell, enjoy the rest of your day.